scratch. Okay, so totally we'll start from the scratch, like what we are gonna do with the cloud and how the cloud will work in the real time, how we will use the cloud in the real time. So everything we will make from the scratch. Okay, fine. So first of all, let us understand what we will do if we go for an IT company. Okay. However, after learning this cloud computing, okay, so we are going to join in IT company. So first of all, let us know like what we will do in IT company, how the things are working. Okay, and in that part where we are going to use the cloud, how we are going to use it. Okay, so we will learn that thing from the scratch. Okay, fine. So first of all, let us understand we have a client. Okay, so here he is the client. Okay, so right now the client need an application. For example, he is the client and he need an application. So any application it might be, for example, it might be a WhatsApp application, Facebook application, Instagram application, any application it might be. Okay, just he need an application, but he don't have any idea like how to develop that application. But he have an idea like if he develop that application, he can able to earn some money. Okay, that is his idea. So what he will do, he will go and approach to multiple IT companies. Okay, for example, there is multiple IT companies are there. For example, like TCS, CTS, Wipro. Okay, so definitely this client will go and he will approach multiple IT companies and he will give his recommend a draft recommend for all the IT companies. Like for example, consider these clients need an Netflix application. Okay, so our client need a Netflix application. So he will approach multiple IT companies. Okay, so first of all, why he have to approach multiple IT companies? Why? Because he wants to know which company is providing in the best cost and in the best delivery time period. For example, if you want to buy the bike, definitely you won't visit a single showroom. Definitely you will visit multiple showroom. Why? Because you wanted to know at what kind of amount they are providing and what kind of least days they are taking for the delivery time period, right? So similarly this client will also seek the same thing in the IT sector. Okay, fine. So right now consider this client gave a rough draft to around 5 companies. Okay, so all the 5 companies will give him the rough draft again. For example, rough estimation, rough estimation. For example, one company will say like we will take 1 year and we will charge around 2 crores. Another company will say like we will take 2.5 years and we will charge 3 crores. Okay, so according to the client, whatever he need. For example, some client the cost will be not necessary. Okay, some client the cost will be necessary, and some client the cost will be not necessary, but the fastest delivery will be necessary. Okay, so according to his perspective, he will choose the company. So let us assume this client selected one of the company. So that company is the TCS company. Okay, why? Because this client is totally satisfied with the uh with the things, with the task whichever they have told, like with the amount, with the delivery time period. Okay, he is comfortable with the TCS company. Okay, fine. So right now he will give the full he will give the full recommend to the TCS company right now. For example, in the TCS company there will be someone called as project manager, so I will mark him as the PM. Okay, okay, so there will be someone called as project manager. To that project manager, he will give his entire TOC. Okay, so in IT company, the TO is very, very important. TOC is very, very important. So sorry, not TOC, it's POC. Okay, yeah, POC. So what is POC? So POC in the sense proof of concept. So in that TOC, the client will be define everything in the sense from the scratch to the bottom. For example, he will say like my application name is Netflix. I want my application in the theme of red and black color. I wanted to upload like it is a um, entertainment category, and in this I will upload the series, I will upload the movies, even I will upload the trailers and all. Okay, so he will explain everything slide by slide. He will explain in that POC. Okay, fine. So by using the POC, the project manager will analyze the entire POC. According to that POC, the project manager will start to develop an application. So, okay, fine. So right now, let us understand what will happen if there is no POC. Okay, what will happen if there is no POC? Okay, so POC in the sense proof of concept, as I told. So right now, assume the Netflix client asked the Netflix application in the theme color of black and red. So consider the project manager is developing the Netflix application in another color combination. For example, he is developing Netflix application in the white and yellow color combination. Okay, and he will deliver the project to the client finally. Okay, but finally, client will be happier? No, he won't be happier. He won't be satisfied. Why? Because the client asked in red and black color, but the project manager developed that in the black and yellow color. Okay, so definitely the client won't be get satisfied. So at that time the client will be asked, I asked you in the red and black, but you developed that in the yellow and black, so I'm not satisfied. But the project manager will say, no, you asked that in the black and yellow color, so I developed that in the black and yellow color. Why? Because here they don't have the POC to talk anything. Okay, so just to understand this concept, by the mutual thing, they will use the POC to understand all the concepts. For example, consider right now they have the POC. Okay, right now they both have the POC as a mutual, and the project manager developed the application like yellow and black color. Think what will happen right now? Again, the client will ask, I asked in the red and black color, but you developed that in the yellow and black color. Okay, so right now the client can able to show this is the POC which I gave to you. So you can check in that POC, I asked that in the red and black color, but you developed in the yellow and black color. Okay, so by the mutual things, they will be using the POC. For the mutual things, they will be using the POC. Okay, similarly, it is not only for the client, it is also for the project manager. So understand, the project manager developed the application according to the client requirement. Okay, in finally the client also can say, I asked you in the yellow and black color. Okay, so at that time the project manager can able to see this POC was given by you. So in this you have defined like you want an application in the color of red and black. Okay, for both of the mutual, they will be having the POC, which means proof of concept. Okay, fine. So hope you guys understand till now. Okay, let's go for little bit forward. Okay, so right now, first of all, there will be one of the team, so they will be start to develop the application. So that team will be considered as a dev team. Okay, so the dev team will start to develop the application. So once the application developer, they will send that develop application to another team. Okay, so that is the test team. Okay, so right here, the dev team will develop the application, which means the Netflix application. So once they develop the application, they will forward that application source code to the test team to test whether the application is properly working or not, whether it have some sensitive files or else it have some legal issues or else it have some bugs. Okay, So to check those things, they will send that to the testing team. So the testing team will start to test that entire application, whether that application is working or not, whether it is properly functioning or not, whether they are getting a proper response or not from the application. Okay, if they are getting something error, so they will mark it out and they will again forward that to the development team. Okay, so right now what development team will do? So finally they came to know where is the bug, so they will start to fix that bug. Okay, so once they fix the bug, again they will forward that to the test team. So again test team will test it. So in the real time, if someone is developing an application, okay, so the entire process will be very easy, but this process will be taking a lot of time. Okay, why? Because they will develop, they will forward, they will test, again they will forward, they will develop, again they will forward, here again the test will happen. Okay, so it will be like a cycle process, dev to test, test to dev, dev to test. Okay, so it will be taking a lot of time. Okay, fine. So finally, if everything is clear, so if everything is clear means, for example, the entire application has the proper code, like there is a no bugs. So finally, they will send all the source code to the dev team again, and they will give a green signal, like it is ready to deploy, ready for the deployment. Okay, fine. So right now, what will happen? So currently, who is having the code? The dev team is handling the code. Okay, so the next step. So guys, right now whatever I'm defining right here, it is just a rough examples I'm giving. Okay, so right here, so assume like the dev team has developed the source code, and right now the next step will be definitely the deployment. Okay, but before deployment, they have to store that source code somewhere, so which can be very easy for use, which can be very easy for taking a backup. Okay, so there is multiple ways to save the things. For example, in traditional way, if we want to tell in the traditional way, we can go for the on-premises server, so which can be also called as a traditional servers. So traditional servers is nothing but, for example, like just now in this today's world we are using the cloud premises like cloud technologies, but before the cloud technologies we were using the on-premises server. So on-premises servers like physical servers, so in IT company they will be called that as a server room. Okay, yeah, so we can go for the physical servers. For a better example way, we can define like in a smaller way, pen drive or else hard disk, but it has lot of disadvantages. So the disadvantages like it can be corrupt. Okay, it can be broken, so like that. More disadvantages we have in the on-premises server, I will define that later. So better we can go for the cloud. So like for a better example, I can define like we can use the uh, on drive or else like terabox. Okay, like that. So if we use like that means there will be we will be having a great backup capacity. Okay, fine. So let's see, I will be storing everything in the cloud. Okay, so right here I used cloud for the storage purpose. Okay, but it is not exactly only for the storage purpose. We will be using the cloud technology for the multiple ways. Okay, so right now we have successfully stored our data in a secured way, and finally the last process, that is called deploy. So similarly, again here, we can able to deploy our application in two things. Similarly, the physical server or also virtual machine. Okay, so the physical server, already I told we have some kind of drawbacks. Okay, so there is no advantage by using the physical servers. So instead of that physical servers, we can go to some other like cloud computing technology, we can able to define that as a VM, which means the virtual machine. Okay, so right here we can able to use the virtual machine. So I will define what is virtual machine. So it is nothing but we will configure the server, for example, how many storage we want, how much RAM we want, what kind of OS we want. Okay, we can configure how we want from the scratch. We can configure. Okay, so in upcoming session we will cover it. Fine. So right now it is one of the virtual machine. We can in other way we can define this as a remote server, which is fully managed by the cloud. So in this virtual machine, we will deploy our application. So for example, right here we was developing a Netflix application. So in the server, I will deploy the same Netflix application. Yes. So right here, finally we have deployed our Netflix application. So they will be creating the VM, which means we will be creating the VM. So we will be creating this VM according to the end user capacity and according to the application size. Okay, so end user depends. For example, for all the application we can't able to say for every application only 100 users only use, for every application only 200 people only use. It depends upon the application popularity. Okay, fine. For example, comparing to Netflix, the definitely the banking, for example, it is a social media. Okay, kind of entertainment. Okay, it is not a social media, it is kind of entertainment. So for this, definitely on the weekend time, the more people will be used. For the banking, on the weekdays time, more people will be used. Okay, it depends. Okay, fine. So the application has been deployed right now. How the user will use. So for that, so consider they are the users. So which means end user. So end user is nothing but the application who is using at the end. So which means the here the requirement process, development process, testing process, storing, deployed. After the deployment, who is using at the final, who is using at the end. So they are considered as a end user. So for example, in one of the example, we are also kind of an end user if we are using a Netflix application. Okay, so they are the end users. So let's understand how this end user will use this application. So there is a simple method so which I can able to define in my way. So I'll define that as a RIR. So in this R in the sense remote. So like why remote? For example, a clear example. For example, we are using a Netflix, we are using a YouTube. Let's take the YouTube as example. So let's assume in YouTube we have millions of videos. Okay, we have billions of videos in YouTube, but it is not locally stored in our mobile phone or else in our laptop. Okay, but we can able to see all the videos, right? It is not stored locally in our mobile, but we can able to watch all the videos. So which means those videos have been stored somewhere remotely. Okay, those videos have been stored somewhere remotely, okay, in one of the physical server, and we are using that, we can able to watch that videos as a remote. Okay, fine. So what is I? So right here I stands for internet. So why internet? Yeah, okay, fine. There is a YouTube videos are available, we can able to watch it, but without internet we can't able to watch it. Okay, so it will be act like a overbridge. So if there is a user, if he wants to use the YouTube, first of all he need a internet access, then only he can able to access that a resource which is available as a remote. Okay, to access something as a remote, definitely we need a internet. Okay, so these both are RI. So this RI will be used by the end user. Okay, so this RI will be used by the end user, and another R is there. So that is nothing but it is rent. So right here I will define which is rent right here. So for example, this server, this Netflix application can be considered as a rent, or is this entire infrastructure also considered as a rent? Okay, so this rent I can able to describe as a subscription. Okay, the user will be using this Netflix application as a subscription. Without subscription also they can able to use some of the applications like Instagrams, Gmails. Okay, fine. So another R maximum it will refers to the client. Why client? Why? Because he is running an application in a cloud premises. Okay, for that he have to pay the rental for the service. For example, for him, the virtual machine is running right here. Okay, so the virtual machine running cost. Okay, the virtual machine running cost, it should be paid by the client. Okay, so however, finally we came to know how the client will earn the money, right? So he will get the money from the Netflix subscription. Okay, fine. So hope you guys understand till now. Okay, so let's go for next. Fine. So yeah, we are done with the diagram. So right now we will go with some of the wordings. Okay, so let's again we will go from the little bit of scratch. Yeah, okay, so this is what I have right now. So yeah, what is cloud computing? So cloud computing is delivery of cloud computing service over the internet. So as I told, so it is a computing service. So if I want to give another example, for example, consider like you're going for the one of the marriage. Okay, you're going for attending one of the marriage. So in that marriage, they won't by entire camera team, okay, entire photography team to cover that marriage. Okay, so they will be calling one of the photography service provider. Okay, so they will get the service and they will pay for it. So similarly, so cloud computing is one of the delivery of cloud computing service. Okay, so they are also providing the cloud computing service over the internet. Okay, fine. So like instead of storing data and running application on personal computers or its local service, cloud computing enables user to access resource remotely on demand. So which means we don't have to store the data on the physical servers which we have. For example, the running application or else the personal computers or local servers. Okay. So instead of this, we can able to run that application or else we can able to use that application by using the cloud computing, so which we can able to use as a remote resource on demand. Okay, fine. Next. So the key characters are like on demand self service, so which means so no human intervention needed to provision resource, so which means we don't need any human right here to to provide that resource. And broadband network access, so such accessible from any device, so which means laptop and phone, etc. So resource pooling, multiple user share cloud resource. Fine. Rapid elasticity, so which means we can able to scale up or scale down when we need it. So and measured service, so which means we just have to pay for what we use, which means we don't have to pay extra. Okay, fine. So right now, so in the real world example, if I want to define, for example, as I told you already, Netflix and Hotstar. So instead of downloading movie, okay, users stream them in real time using cloud service. So which means they will stream real time. Okay, for example, in the olden days, we were using the for example, CD, DVD to watch some of the movies, which means we have stored that things in the one of the physical servers, physical devices. Okay, so right now we don't need those things. Okay, fine. And another example like Google Drive and OneDrive. So users store files online and access them from any device from anywhere. Okay, next. So advantages of integrating cloud service with traditional IT cloud solutions, traditional IT solutions. So for example, cloud integration enhance traditional IT infrastructure by adding flexibility, security, and cost saving. Okay, fine. So for example, so let us say I already told you like we have some of the disadvantages in the traditional servers. Okay, traditional servers nothing but, as I told you, the physical servers. So let's see for example, let's see as an example. So these are the things on premises server. Okay, so which can be also considered as a traditional server. So in this, what kind of drawbacks we have? Let's cover. For example, consider these are the huge level of a server room. Okay, so which means if I want to start a company before the cloud, okay, I'm saying before the cloud, if I wanted to start a company, definitely I have to buy these servers. So I cannot able to buy these servers by using the lakhs, okay, lakhs of rupees. I have to invest around crores, like 2 crores, 3 crores. I have to invest a lot. So after investing, I can able to buy the servers. But after buying those servers, I have to allocate those servers somewhere, which means I need a huge space. I need a huge space to allocate those servers. So for that space, I have to pay the rent. For example, in a commercial manner. So definitely the commercial manner will be high in the cost. Okay, fine. So finally, I got the place to allocate my servers. After allocating my servers, I have to configure it. Okay, for the configuration, again, I have to pay. Okay, once I configured, I want the manpower to maintain everything. And similarly, I have to pay the electricity bill for all of the server. And even I have to initialize the ventilation for the cooling of for the server. Okay, so these things are there. So which all are considered as a uh, drawback. Which means I have to invest a lot. Okay, so and if these all are not a drawback, if these all are not a drawback, there is one more biggest drawback is that. So that is nothing but nature disaster. Okay, so nature disaster is nothing but, for example, consider here it is a server room, and it is located in the one of the place. Okay, so what will happen for the in the nature disaster? There might be like fire accident, there might be like a earthquake, okay, tsunami. So anything can be happened. So let's assume like there is a flood. Okay, one of the flood came and covered the entire building. Sorry. So what will happen that time? So definitely all of these servers will be dissolved in the water. So which means that every data will be corrupted. So for example, consider in this servers I was running an application called SBA application. From past 15 years, I'm running a SBA application. So from the past 15 years, transactions of every users will be dissolved in the water in a single second. So what will happen at that time? We can't able to get any data backup, right? So that is the biggest advantages in the that is the biggest advantages in the physical servers on premises server. Okay, fine. So yeah, those can be considered as a traditional servers also. I will define how the cloud computing will work, like cloud premises. I will define. Fine. So let's cover this. So cloud integration enhance traditional IT infrastructure by adding flexibility, security, and cost saving. So benefits are cost saving and scalability, security, accessibility, disaster recovery. So for example, cost saving, how it will work. So no upfront investment in hardware, only pay for usage. So which means right now till now I was explaining about the disadvantages of the traditional servers. So these are the advantages of the cloud premises. So which means, as I told you, we don't have to invest for the hardware. So they are defining these things as a hardware. Okay, so we don't have to invest. So the cloud service provider, they will provide the service, so which means they will be having all the service, so we will be using those service as a virtual, okay, by the remote. So right here, no upfront investment in hardware, only pay for the usage. Okay, so they will provide, we will use that as a remote, and we can able to use those resource which we want, how we want, from wherever we want, and just we are just gonna pay for them for what we use, we are not gonna pay for extra. Okay, so right here we have the advantage of cost saving, scalability. Okay, so automatically adjusts resource based on the demand. Okay, based on the demand in the sense, for example, if we go for the social media, okay, if we go for the social media category, one application, so we can't able to define at what time how many users will be used that application. So for example, in the early morning, definitely the social media application, there is less users only in the early morning. Okay, like by the 10 o'clock, 11 o'clock, it will be in the mid range, and afternoon it will be also in the mid range, but at the evening time, like after the office, after the school, after the college, in the evening time, definitely there will be lot of traffics. Okay, so lot of peoples will be start to use that social media application, so at that time definitely the traffic will be hit in the peak. So at that time it will automatically adjust based on the demand. Okay, fine. And security, so in this, they are providing the data encryption, authentication, and access control, so which means they are defining it is totally secure. So right now everyone has started to use the cloud, so which means, for example, if you are gonna deploy an application in the cloud, you can able to encrypt yourself your data. Okay, you can able to encrypt your data, and after that you can store your data in the cloud. Okay, so security can be provided from their side also. If you want more security, you can also encrypt your data from your side. Okay, so security is also available. Accessibility, so like as I told you already, so work from anywhere using cloud hosted application. So like as I told you already, the same example like Netflix, Hotstar, YouTube, etc. And disaster recovery. So cloud storage ensure data backup and recovery in case of failures. Yes, we have this future. So this is the one of the greatest future which we have in the cloud technology and which we don't have in the on premises. Okay, this last one, disaster recovery. Okay, fine. So let's go for next. Yeah, so real world example for this one. Yeah, so right here, banks. So while core banking, so while core banking system run in on-premises data center, customer portals and mobile apps are hosted on the cloud for scalability. Okay, so which means they are defining like the, so currently in some of the banking, okay, not all the banks, in some of the banks, they are still running that application the on-premises server itself. Why? Because for a single day they will be having crores of transactions. Okay, so they can't able to migrate immediately. Okay, for those purpose, in those conditions, still some bankings are using the on-premises server to host that application. But for the customer portals and everything, which is the like a UAX part, those are things are running in the cloud for the scalability, for the better scalability. Okay, so this is the banking application is one of the best example. And for example, the e-commerce, okay, like Flipkart, Amazon. So cloud ensures smooth operation during Diwali sales, handling sudden spikes in user traffics. Yeah, so this is nothing but, for example, Flipkart, Amazon, say, so the application flow will be equal. For example, today evening 5 o'clock, assume like there is a 5 lakh requests are going on per second. So definitely tomorrow also same 5 lakh request, around 5 lakh request will be the same. Okay, but it won't be same all days. Why? Because they will give some offers like Big Billion Day and Great Indian Festival. So those days the request will be totally different. So for example, on the normal day, consider like they are getting a 5 lakh request per second. Okay, just a rough example. Okay, they are getting 5 lakh request per second. Okay, but the same thing won't be happen on the Big Billion Day or else in the Great Indian Festival. So definitely the request would be like around 10 lakh, 15 lakh, 20 lakh, anything it might be. Okay. Why? Because they have announced the offer. So which means the user can able to buy something in the lesser cost. Even if they are not gonna buy, they will just go for the application and they will check whether what is the cost of my current phone, or else if he wanted to search something else, okay, anything it may be, okay, definitely the user will log in. Even if they are not buying also, they will just check the price. So for that reason, definitely the traffics will be very high. So those things can be, we can able to run those applications smoothly by using the cloud. Okay. So next, architecture of an application which is deployed on the cloud. So a cloud-based application is typically designed with multiple layers to enhance performance and scalability. For example, yeah, one application. So there is multiple types of application. For example, like one tier, two tier, three tier. So totally three tiers are there. So this presentation layer, user interface. So this can be considered as a one tier, single tier. This first one. Okay, and three tier. Okay, I will define about the two tier later. Three tier, which will contain all of this. Okay, so which means the web layer, which means presentation layer, application layer, and database layer. So all three together can be considered as a three tier. In this, two tier is also available. So that is nothing but, definitely there will be database layer in the two tier. Okay, in the two tier definitely there will be DB layer. With that DB layer, there might be presentation layer, or that might be application layer. In a better way, we can able to define the two examples. So presentation layer and the database layer, or else application layer with the database layer. Okay, so those are two tier. If you guys didn't understand, I will explain using the paint. So for example, consider like there is an application. Yeah, let's assume it is a, yeah, let's assume it is an Instagram application, and here we have the user. So right now what will happen? So it is the entire Instagram application, and as I told, there will be totally three layers. So those layers are web layer, app layer, DB layer. So totally, as I told you, totally there will be three types of layers. Okay, those three will be there. So even there will be another name for this. For example, we can consider this as a web app, and DB. Okay, fine. So let's understand it clearly. For example, what is web server? What is web layer? Which means what is presentation layer? Yeah. So as I told you, there is a one tier. So nothing but this is that one tier. Okay, this is the one tier. So let's understand why it is called as a one tier and why it is called as a web server and else why it is called as a presentation layer. For example, if you go for the Instagram login page, let me go. Yeah, okay, fine. So we will take this as an example. So this is how the Instagram login page will be looks like. Okay, fine. So in this page, this is considered as a presentation layer or as a web layer. Okay, so why? Because it will be considered as a static. Okay, it is also considered as a static one. Okay, static. It is a static. So let's understand why this is considered as a static. Why? Because for every user, okay, for every user, okay, so even if they have the account, even if they are not having the account, okay, so whatever it is, if they go for this web page, okay, if they go for the login page, the page will be remains same for every user. Okay, for every user, the page will be remain same. So for example, if I'm trying to go for the login page, the same thing will be defined like enter the username, enter the password in the same design, the same UI. Okay, so for everything, for everyone, this presentation layer will be the same. Okay, yeah. So once we cross the presentation layer, then only we can able to come for the application layer, which can be considered dynamic. And let's assume why it is considered as a dynamic. So why? Because, so as I told you, this is the presentation layer, which means a static. What will happen if I give my correct credentials, username and password? If I give my correct username and password, definitely I will be in the logged. Okay, I will be logged in my Instagram application. So which means where I can able to see different posts. Like for every user, the same post will be not shown. Okay. For example, if you guys log in the Instagram, you people can able to see some other different reels post. Similarly, if I log in, I can able to see some other different reels post. Why? Because it's according to the user. Okay, so I may follow some of the page, you may follow some of the page, it depends. Okay, so it is dynamic. Okay, so it is dynamic, so which means the user, for every user the content will be different after the login. Okay, so that's why it is defined as a dynamic and it is considered as an application layer. So after the application only we have the DB, so it is also kind of a dynamic. Okay, so which means consider in my Instagram application, if I close my application, which means I was using the application and after that I have uploaded one of the post in my Instagram application and after that I have closed my application. So what will happen? Definitely some people might be comment on that. Okay, so later, which means I didn't do any changes, automatically the command will be saved on my DB, right? So that is dynamic. The command, the likes, or as the post which I have liked previously. Okay, everything will be stored in the database. Okay, so that's why that is dynamic. Even if I didn't do anything, some people can be like the post, some people might be command the post, so it will automatically change as a dynamics one. Okay, yeah. So this is the DB. So let's understand one more thing. See how they have given the clear authentication of the application. So for example, he is the end user, which means he is going to use its application, so he can't able to use application directly, which means without login he can able to use that application. or else without login he can't able to go for the DB also. So first of all, the user should enter in the application, which means a web layer, a presentation layer. Once he give the login credential, then only he can able to go for the application layer. Then only he can able to access the DB layer. So it is not only for the Instagram application. This is for banking application we can able to define. So without login, we can't able to go for the application layer, which means application server. Okay. So even if you log in and you close your banking application, if you go for your banking application again, from the beginning itself, it will ask again the password because for more authentication. Okay, fine. So yeah, this is the thing, which means the application architecture. So three-tier architecture. This is the three-tier architecture we can able to define. Why? Because in this we have the web layer, app layer, DB layer. In another way, presentation layer, application layer, database layer. Fine. So all three together we can consider as a three-tier architecture, and only web server we can able to consider as a one-tier architecture, and two-tier architecture we can able to define web plus DB, web plus DB, or else app plus DB. That is the two-tier architecture. So definitely in the two-tier architecture, the DB will be contained. With this DB, there might be a web server, or else with this DB, there might be an app server. Depends. Okay, fine. And next. Yeah, for example, the real world example, Swiggy and Zomato's. Okay, so like web, so which means the UI interface, the user will place orders. So while we will place the order, okay, so while placing the order for every user, the thing will be same. Okay, and after that, the backend, so which will be maintained by the AWS or GCP or Azure, which means they are the cloud service providers. Okay, so managing orders, processing, and delivery tracking, those things will be runs on the cloud platform. Database, so we will be having the multiple engines like MySQL, MongoDB, PostgreSQL, etc. So for the stores, restaurant, users, and order details, those things will be stored in the database. So this is just a rough example for this. Okay, so I will give you more example while we'll go for the advanced topics. Okay. So cloud service and deployment models. So this is very, very important. So let's understand there is something called as IaaS, infrastructure as a service. Okay. And yeah, actually these are three delivery models of cloud. Okay. Infrastructure as a service, platform as a service, and software as a service. These are three delivery models of cloud. So in this, first of all, let's understand the infrastructure as a service. For example, rent virtual machine. Okay, network and storage. For example, we can able to rent this virtual machine, network and storage by using the AWS cloud or GCP. Okay, anything. So renting a virtual machine and pass platform as a cloud. So cloud host platforms for developers. Okay, so Google App Engines, AWS Elastic Beanstalk, software as a service, fully managed application, for example, Gmail, Microsoft Office. Okay, fine. So right now, let me give a clear example. Okay, let me give you a clear example. For example, renting a virtual machine. So you can't able directly rent a virtual machine. You have to configure your virtual machine by yourself. For example, as I told you already, how many GB of the storage you want, how many GB of the RAM you want, what kind of network you want, what kind of the firewalls you're going to set up, how many of the storage you want, what kind of the OS you want. Okay, everything will be defined by yourself from the scratch. Okay, so that is infrastructure as a service, which means for the thing you will be creating the entire infrastructure. Okay, yes, those things are this platform as a service, which means already they will provide some of the platform which will be the pre-configured, okay, which will be the pre-configured. So you will just use it, and you will also configure something in that. That is the platform, which means they will provide some platform. That platform you will configure according to your usage, and later you will use it. So that is the platform as a service. And after that, we have something called a software as a service, which means fully managed application. Like already we are using the Gmail, Microsoft Office, WordPad, right? So like, yeah, Gmail is the best example. Fully managed, they have created the entire application, and they have provided this for the user. So user can use however they want. They don't have to configure anything, right? So this is the software as a service. So these three are the delivery models of the cloud. Okay, so right now I will give you a better example. So infrastructure as a service, so which means renting a self-driven car. One second. Yeah, renting a self-driven car, so which means you will manage fuel and maintenance, right? You are going to rent a car, that is fine, but they are not going to give the fuel, they are not going to drive. Okay, so you will rent, you will manage. As I told you, you will be creating the infrastructure, you will be creating everything from the scratch. Okay, same thing which I told you already. Okay, and here pass hiring a Uber. Okay, you just ride, drive, manage the car. Okay, driver, you just ride, so driver manage the car, which means as I told you already, they will be providing a platform. Okay, so that platform right here it is. So driver manage the car, you just ride. Okay, so which means as I told you already, there will be something they will provide like a pre-configured. So we will be using that. Okay, and right here SaaS, software as application, so which means taking a public bus. So you don't have to do anything, just you're going to travel in the bus. Okay, so the fuel, the driving things, everything will be covered by taking care by the public bus itself. Okay, everything managed, just enjoy the ride. Okay, so hope you guys clearly understand about the infrastructure as a service, platform as a service, and software as a service. Okay, fine, so let's go for next. Okay, it is kind of a bit interesting topic. So it is called as fog computing. Okay, so let's understand what is fog computing. So fog computing extend cloud computing by bringing computation closer to device, reducing latency. So the main thing for what reason we are using the fog computing, it is just to reduce the latency, reduce the delay time. Okay, for example, why fog computing needs needed. So cloud is centralized and may causes delay. Okay, so cloud is centralized, which means cloud providers are centralized, which means they will be having the data center in some of the location, which will be centralized. So that can be process some delay time, downtime, latency. Okay, so IoT devices, so like CCTV, camera, sensor, generate huge amount of data. Okay, so it will generate huge amount of data like CCTV cameras and sensors. Okay, fog computing process data locally before sending only necessary information to the cloud. Okay, so if I wanted to give a clear example, okay, let me give a clear example. After that example, we will go with this. Okay, fine. We'll go with this example. After that, I will give you another example. Okay, so smart traffic lights. So sensor direct traffic condition. Next, fog computing. So yeah, we were covered about, yeah, sensor detect traffic conditions and adjust signal in real time without waiting for the cloud instructions. Okay, so for example, consider there is a road, okay, and there is an accident. Okay, so that accident can be uh, detected by the sensor. Okay, that accident can be detected by the sensor. Okay, but if something is happened, like for example the accident has happened, that should be cleared very fast. Okay, that should be taken care as soon as possible. So if we are running the sensor or a CCTV camera in the cloud. Okay, so it may cause delay. It may cause us delay time. Why? Because the cloud is totally centralized. Okay, so why? Because the data has to travel very long, where the where the physical service, where the cloud service is located, the data has to be traveled that much long, and it have to trigger and return back. It have to come. So before that, anything can be happen in the signals. Okay, so to avoid those things, they will be using the fog computing. Okay, so which means it process data locally before sending only necessary information to the cloud. Okay, so which means it won't go for the cloud to provide some of the things to manage to tackle something. Okay, so it will decide itself in the by using the local signals. For example, let's see for another. So Apple Watch analyze heartbeat data locally and send summaries to the cloud. Okay, so which means the Apple Watch, so if the person is wearing the Apple Watch and he is getting some of the like heart stroke, means definitely that will the if the watch process in the cloud, it the response will be very very low, which means it will face some latency, downtime. Within that, anything can be happen for that person. Okay, if it calculated by itself locally, the result will be very very faster. Okay, so in another way, in another example, for example, the self-driving cars. Okay, the self-driving cars, there is in the fog computing technology itself. So for example, if somebody comes in the front, means at the time definitely the car has to be brake. Okay, what will happen if they use the cloud technology in that place? So what will happen? It have to, the sensor should have to work. After that, sensor should detect. That detection should go to the cloud, which is centralized very far. Okay, and it have to receive the data again. Then it have to puts the brake. So within that, definitely the accident might be happen. Not might be, definitely the accident will be happen. To reduce those things, they will be using the fog computing, which means the local server which will be designed by itself. Okay, so that is the fog computing. Okay, then cloud supports for blockchain, AI, analytics, and software development. So cloud in AAML. So AI models are trained using high performance cloud GPUs. Okay, chatbots, image recognition, and voice assistant use cloud based AI. So which means like cloud supports these things. Okay, right now clouds used to support for everything. So mostly the like training some of the models. Okay, and for the voice assistant, chatbots, there is the cloud technology. Okay, cloud and blockchain. So cryptocurrencies like bitcoins. Okay, so those things are running in the cloud servers itself. So there is something called as blockchain as a service. Okay, so which means AWS manages blockchain. So simplifies blockchain implementation. So we'll be having the example for this also, real world example. So cryptocurrencies. So uses cloud servers for decentralized transaction. Okay, so for the cryptocurrencies and for the Google Photos, AI powered face recognition groups similar photos using cloud based ML. Okay, so which means for this also they will be trained some of the machines, some of the models, and by using those models, there will be groups like like we already have been used like a Google Photos, right? So that will be categorized like grass and white background, beach background, group photos, selfies. Okay, so those things like face recognition. So that is also AI powered, which is running in the cloud service technologies. Okay, cloud supports. Fine. Yeah. So let's see again back to the same topic again. So which means traditional data center versus cloud computing. So these are the futures. Okay, so cost wise. So let's see up in the cost wise. So high upfront investment in the traditional. As I told you, if we are going for the physical server, we have to invest a lot. Okay, but in the cloud computing, it is in the pay as you go method. So which means you have to pay only for what you use. Okay, and scalability. So limited by the hardware. Okay, so which means there will be limited hardware. For example, if you have buy some of the hardware and you're using it for from past few days, and suddenly consider you're running an application in your hardware, and suddenly the traffic got higher in the peak. At that time, you want extra hardware. At that time, you can't able to go and purchase hardware. Why? Because it is not like a small thing which will be available nearby shop. Okay, so it is the biggest server. So we have to go and purchase. So limited hardwares. Okay, so limited hardwares. But if you go for the cloud computing, it is virtually unlimited. Just it will manage by itself. Why? Because we have like auto scale up and auto scale downs, right? So we don't have to think about the scalability. Okay, so these are the drawbacks right here. These are the advantages right here. So drawbacks of the traditional server, advantages of the cloud computing. And maintenance required directed IT staff managed by the. Okay, fine. So till this, so requires, so which means we have to allocate a manpower. We have to allocate a manpower to manage those hardwares, to manage those physical servers for the maintenance. But if you go for the cloud, managed by cloud providers, which means the cloud providers like AWS, Azure, GCP, so they will be managing entire thing from their side. Okay, so it will be very, very smooth in the cloud computing. And after that, in the security basis, so physical security needed. Okay, physically the security should be needed. And so in the cloud computing, multi-layer security. Okay, so multi-layer securities are available like encryptions, IAM. So about this IAM, we will cover deeply inside the session. So right now, as we know what is encryption, we know encryption like clearly. For example, if I wanted to say, let's assume like we are using the WhatsApp, we everyone are using the WhatsApp. So in that WhatsApp, we can able to see something called as like end-to-end encryptions. So let's understand what is end-to-end encryptions. So let's assume like I'm a sender, and there is one of the receiver. Okay, there is a sender and receiver. So if I'm sending a message to the receiver, for example, I'm sending a message to the receiver like, hey, okay, so that message will travel to the receiver. So while the message will be travel in between, it will be in the encryption mode, which means it won't be the readable format. It won't be in the readable format. It will be in the unreadable format. This encryption text will be decrypted only in the receiver's WhatsApp. While the user will receive the message, then only the text will be decrypted. Then will be it will convert as a readable format. So that is the encryption decryption. Yeah. So which means in the cloud computing, the encryption is available. Okay, fine. So real world examples. So banks and government agencies. So prefer private data center due to security concern. Yeah, definitely. Okay, so like government agencies like banks. So definitely banks. It depends for everyone. Okay, so every each and single rupees is definitely it will be worth. Okay, so which means banks should be secured, and even then government agencies should be also secured. Why government? Why? Because if I'm running the government things in the cloud technology, definitely the cloud service will be in another country. Okay, so if they want means they can hack. Okay, it is not possible, but even then it should be very, very confidential. Okay, so definitely they will prefer a private data center due to the security concern. Okay, so like social medias like Facebook, Twitter, so relay entity on the cloud computing for scalability. So yeah, as I told you already, for social media the traffics will be high and low at any time. So for that we need the scalability. So so for that we can go for the cloud. Okay, fine. Next. So data center key component. So what are the components are available under the data center? So let's assume like servers. So host application and database. Okay, so like database engines will be work, and application hosting servers will be work. Okay, so those we can able to consider that as a servers. And after that, like a storage, for example, hard drives like SSD, NAS, SAN. Okay, so these will becomes under the storage categories. And network, so like switches, routers, firewalls. Okay, so this will be considered the network categories. Okay, and power supplies like UPS, backup generators. So these are the things used for the power supplies, and cooling system like preventing overheating, like ventilations and all. Okay, so these are all the data center components. So not only this, apart from this, there is multiple things. Okay, for example, the cabling, like we have to cable from server to storage network. Okay, those things. So these are the major components we are seeing right here. Okay, let's see here real world example. So Google data center, so massive facilities hosting Gmail, YouTube, and Google Drive. Okay, yeah, fine. So they are hosting massive things like YouTubes and all, Google Drives, Gmails, etc. Okay, so let's go with the problems with traditional data center. So high hardware and maintenance cost. Okay, so we have to use the hardware, like huge of hardwares, and for that huge of hardwares we have to definitely invest maintenance a lot. Okay, so maintenance cost, as we covered already, limited scalability. Okay, required new purchase. So if there is limited, okay, for example, consider like you are using a pen drive which is around 1 terabyte. Okay, you have used that pen drive, but you want the all the data which is available in that pen drive. Okay, so definitely what you have to do, you have to you have to purchase a new device, right? So that is require new purchase. We have to purchase the thing. Okay, and due to hardware failures, yes, it can be happens. Why? Because it might be because of the high traffics, or it's overheating, or it's kind of a corruptions. Okay, so anything. So risk of downtime due to the hardware failures. Okay, expensive security measures. Yeah, so hope you guys understand. Okay, so these are the drawbacks of the traditional data centers, traditional servers. Okay, so for example, Instagram 2019 outage, a server failure caused around 10 hours downtime. Okay, cloud-based architecture prevent such failures. So which means in 2019 they were using a physical data center, physical servers for the Instagram. Okay, so at that time the server failure cost around 10 hours of downtime. Okay, so if they were using the cloud-based architecture, that failure might be prevented. Okay, fine. So let's cover futures of cloud computing. So like scalability, so handle millions of users without downtime. As I told you already, we have a features like auto scale up and auto scale down. We can able to scale up. Okay, we don't have to think about the backend servers and all. Okay, and security. So as I told you already, like encryptions is available, identity management is also available, which is in another way we can able to call it as a IAM, which we cover right here. Okay, fine. And disaster recovery, so automatic backup prevents data loss. So disaster recovery, it is one of the advantage in the cloud computing, which is not available in the on-premises server, which means in the traditional servers. Okay, if once we lost the data, we can able to get the data from another side, another location. I will define about that clearly later. Okay, multi-tenancy. So resource shared among multiple customers securely. So multi-tenancy is nothing but like kind of a grouped one. Okay, so in every group in the backend, the resource will be shared. Okay, so it will be smooth to use. Real world example. So automatically scale resource when a video goes viral. Okay, hope we can able to understand. Okay, next one, enabling technologies in cloud computing. For example, virtualization like VMware, KVM. So running multiple virtual machines in a single server. Okay, yeah, it can be happen. We can able to do this. Okay, running multiple virtual machines in a single server. Yeah, we already have done this in the on-premises server also. Okay, but that has a drawback. But it can be possible in the cloud premises. So you might be people's like asking question like how it can be possible in the on-premises server. How can we run multiple virtual machine in a single server? So that is nothing but, for example, consider like we are using a computer. In the computer, if you want to run two same application, how can I able to run two same application in a single server? For example, I'm having a computer. In the computer, I have to run two uh, two Java, okay, or else two Python, different Python version. Two Python I have to install, or it's the same version of Python. Two Python I have to install, or it's two application I have to deploy. How can I do this? Yes, I can do this by using the hypervisor. By using the hypervisor, I can bring some guest OS. By bringing the guest OS, I can able to run two application in the same version, or else two application in the different version, or else I can able to deploy two application in a single server. It can be by using the hypervisor, by bringing the guest OS. Okay, but instead of that guest OS, right now we have a great opportunity, like we have great futures that is called as virtualization, where we can able to use the VMware's VMware's like containers, etc. Okay, and after that containerization like Dockers and Kubernetes, like portable lightweighted application. So we will go through about this in upcoming sessions. Okay, serverless computing like AWS Lambda, so run code without managing servers. So which means there will be something called a serverless server. So in that server, we just have to run some code. We will define some of the function in that code. The thing what we define in that code, according to that, it will work. It will trigger and it will work. Yeah, and yeah, for example, Google Stadia, Xbox, cloud gaming. So games run on cloud servers, streamed to users. Okay, and evaluation of cloud computing. So these are nothing but what we are using right now. So for example, in 1960s, mainframes and time sharing came, and after that in 1990s, virtualization technologies was deployed, and after that in 2000s, AWS launched cloud service. For example, exactly in 2006, they have launched their AWS cloud service, and in 2010, AAML serverless computing they have deployed, and after that in 2020s, edge computing, blockchain, quantum computing, which means the current scenarios. Okay, we are using those things and all. Okay, real world example. So NASA in 1960 used mainframes for computing, now use cloud-based AI for the space missions. Okay, so which means they just jumped from 1960s to 2020 directly. In this is real world example. Okay, fine. So final thing, cloud categories. So very important. So like public cloud. Okay, so Netflix, define Netflix. AWS host streaming. Okay, and private cloud banks. So secure internal data storage, hybrid like hospitals, private data, cloud-based report. So public cloud, which means like totally we are using the AWS for hosting. Okay, totally we are using a single one. Okay, so private like banking, so like internal data storage, data storing. So why? Because it is a banking, so definitely we have to store our data very very securely. For that, they will be using internal data. So that is internal data that can be considered as a private cloud. And hybrid, so hybrid means public and private both will be included. For example, private data which will be stored in the internal, and cloud based reports which will be streaming in the cloud basis. Okay, so these are the cloud categories. Yeah, okay, fine. Yeah, guys, so for this session we have done with the session.